Hey there, folks. It has occurred to me that I have not shared my answers to the homework problems in a little bit. So here I have the answers to the 2.1-2 practice and the 2.3/2.4 practice problems. You should obviously try them on your own first, but then compare my work to yours and see if you're on the right track. So to begin with, the first problem in 2.1-2, it is given that triangle LMN is congruent to triangle GHT. Name all congruent parts. Well, remember we said the order is super important, and for example, if L is the first letter and G is the first letter in each of those congruence statement halves, then that means that angle L is the same as angle G, which I think you can kind of see in the picture as well. Also, you can do that same sort of thing with the segments, like the second two letters here are MN and the second two letters here are HT, which means that segment MN should be congruent to segment HT, which I think, again, you can see that if you look at the picture. Note also that it would be okay to write those in the reverse order, like if on yours, for any of the segments, if you have N, M, and T, H, that would be okay too. That would just be the same segment, just, reversing the order of the letters, going from N to M is the same as going from T to H. Okay? Make sure you have angle symbols along with the angles. Either use the less than sign like we've been using in class, or get the angle symbol from somewhere and copy and paste it in. No symbols for the segments, though. No symbols for the segments. Question 2. EDC, triangle EDC is a rotation of triangle ABC around C by 180 degrees. Why is this incorrect? Well, if this is rotating around C, then C should be corresponding to C, right? Like those are clearly vertical angles. Those two should be matched up with each other. And A should be matched up with E. So frankly, the only problem is that the letters are in the wrong order. Sure, those triangles are congruent, but you're supposed to have the corresponding points in the same order. Okay. Question 3. Now this one takes a little doing. There's 6 statements here, and I feel like this bears some talking about. So I'm going to go through each one and say why I did or did not choose it. So the first one, triangle FGH is congruent to triangle FEH. If I even just look at the first 2 letters of each, this would imply, based on what we've talked about, that segment FG is the same as segment FE, and I think you can quickly tell at a glance that this is not true, which is why I did not select this one. Likewise, if I look at the second triangle congruent statement, EFH congruent to GFH, well, let me try the same trick there. Where is segment EF? Segment EF is in the top triangle here, and segment GF is, that's the same thing. Oh man, that's still not right. It's still not right. Those parts do not match up. So that is not a correct congruent statement. What would be a correct one? I guess you could say triangle EFH would be congruent to triangle, let me make sure I'm doing this right, GHF? Let's see if that looks right. So EF is congruent to GH. Is that true? Yeah, that's true. And then the second 2 letters is FH congruent to HF? Yeah, it definitely is also. HF and FH, that's just 2 names for the same segment. It's unusual that it gets reversed here, but that's, I guess, a consequence of that rotation by 180 degrees. So this would be a correct triangle congruent statement. Okay, moving on. Next, I said this one is actually true. Let's see it in practice. So KHE is congruent to KFG. Let me draw in those angles on the picture. Here is KHE, 38 degrees. And here is KFG, also 38 degrees. Looks good. That's why I said that one is fine. Okay. The one after it, though, isn't. So why? GHK congruent to KHE. Let's see that. So G, then H, then K would be this 25 degree angle. And then KHE, that would be, let's see, K, then H, then, nope. those angles are not the same, so those are not congruent. Okay, that would not be accurate. Okay, EH congruent to FG. Well, is that true? Where are those segments? EH and FG, that would be, okay, here's EH, here's FG over here. Now, oh man, somebody might say, yeah, those segments are the same length, Mr. Martin. However, I'm going to be really technical here and say that those are not in the right order. It should be EH is congruent to GF, because then I think we can all agree that angle E is the same as angle G, right? So those should be the first letter in each one. I wrote this wrong. I'm just seeing it now. Should be, sorry, the other half should be GF. My bad. But the point being that if it's written in this direction, that says for the segment, start at E, then go to H. And for the other one, it would say start at G, go to F, and that actually matches up in this picture. So that's why this one doesn't count. But the last one, GH congruent to EF, let's see about that. Where are those segments? GH, clear off some space here. Here's GH, start at G, go to H, congruent to EF, start at E, go to F. Yeah, I feel good about that. That's written in the right order and everything. And those segments are the same length. So great. Good, great, great, wonderful. Move on. You can read my response here, but again, it basically boils down to the letters being in the wrong order, right? B should correspond to K. So a correct statement would be something like this. BOER is congruent to KOED. Lastly, oh boy, I just went through and I marked everything that they said on this picture. Like I started with all the side lengths. I said AB is the same as DC. And so I drew one line on AB, one line on DC. And then I said, okay, second two letters, BC, should be the same as BC. Oh, that's the same segment. So obviously it's congruent to itself. And then the third segment, AC, should be the same as DB. So here's AC and here's DB. So I marked all of the segments using those congruence statements that were given to me. And then I used that information to write a correct congruent statement for the red and blue triangles. Okay. You'll notice that even I marked some angles in here. Like I saw angle A. Angle A is between the segments with 1 mark and 3 marks, just like angle C is between the segments with 1 mark and 3 marks. Well, that tells me that angle A is corresponding to angle C. And if I go from A to B for my first two letters, that's going from A along the segment with 1 mark to B. Then I should go from C to D, again, along the segment with 1 congruence mark on it, so that those match up. Hopefully that's good for you. I'm going to jump over to the 2.3, 2.4 practice. So first question, which of these things are true? Well, if we can take ABC onto EDF through rigid transformations, okay, then does angle A match up with angle F? No. Because angle A should match up with angle E. So yeah, the first one doesn't count, but the second one's okay. Angle B and angle D should match up. Yeah, you can see that in these pictures. They both kind of look like 90-degree angles even, but they're also in the same order here. Second letter here means those angles are should coincide, should be corresponding. Segment AC coincides with EF. Yeah, I think so. AC is to EF. Yep, first letter, last letter. First letter, last letter. That's good. And so on. I think I'm going to, for the sake of time, just move on to the next question. Okay. Triangle MON is congruent to triangle TUE. These are the things that I said are true. I also drew a little picture. Obviously, we don't have one to begin with here, but if you want to make one to help you out, I think that can be useful. I made the pictures and then I marked all of the things that I knew had to be congruent, like the first two letters MO means that MO, segment MO, should be congruent to segment TU. And then I just, followed things down the line to make sure that all of those angles were congruent. Like, I'll just show the last one. NOM is congruent to EUT. That would look something like this. Angle NOM means this angle right here between N and O and M, where O is the vertex. And is that congruent to EUT? Well, start at E, go to U, end at T. Yep, sure enough, those angles, they're in the same place. So those angles are congruent. Okay, you can read this if you want to. I don't care for this kind of argument, if I'm being honest, but apparently we need to make it from time to time, so we can talk about this in person more if you want to. Okay, again, this one's actually a better question. I think we need to be able to do something like this. So how do you use rigid transformations to take XYZ onto BCA? Okay, as drawn. Okay, if I translate from Y to C, then Y will line up with C, obviously. Okay. After that, if we rotate so that X prime lands on B, then we're going to have two of the points in the right places. And then the only thing that's left is to get Z onto A, right? And because C and B need to stay in the same spots, I think it would make sense to reflect over line CB. And then those 2 points will stay where they are, and Z prime, which is actually out here in my picture, it would be like somewhere around here. And then if you reflect it across line BC, it'll land where A is right now. Okay. On the next question, you can see what I wrote here. It is a translation to get two of the points in the right places, and then a reflection to get R prime to land onto P, which must make the triangles congruent since all three of the vertices coincide. They would be in literally the same places. Here's a table, and corresponding parts of congruent triangles are congruent. So we talked about how to do this earlier, but here's another example of it. Let's see, on question 7, what is the least amount of information you need to construct a triangle that is congruent? We said so far that we have 3 options to say that triangles are congruent. If they have all 3 sides congruent, we call that the side case, then the triangles must be congruent. Or if we have 2 sides and their included angle, we call that side angle side. That would look something like this. If I knew JL and JK and angle J in the middle, then I could say that, if I had another triangle with the same 2 side lengths and the same angle in between, then they would have to be congruent. The other case that we've discussed a little bit would be something like this, 2 angles and their included side angle. So something like this. If I knew the measure of angle J and the measure of angle K and the length of segment JK, well, then I could duplicate that in a second triangle and it would have to be congruent to this one. Okay, here's a card sort. And last question, kind of seen this before, but again, just make sure that the corresponding points are in the right order. If you're reflecting over this line, EF, then A would land on D, B would land on C. So those points should be in the same order when you're doing your congruent statement. Here is one of them that would be correct. Let us know if you have other questions.